Imagine this. You're sitting in your room, staring at the stars through your window, when suddenly, a strange device materializes in your hand. It's a telescope, but not just any telescope. This one can reveal secrets of the universe that no one has ever seen before. You point it at the moon, and suddenly, the moon isn't the smooth, perfect sphere you've always known. Instead, it's a rugged, scarred landscape, full of craters and mountains. You zoom out and see stars you've never even dreamed of. And then, to your astonishment, you discover 4 tiny moons orbiting Jupiter. This is what Galileo Galilei experienced in the early 17th century, and it changed everything. In 1609, Galileo Galilei, a mathematician and professor at the University of Padua, heard rumors about a new device called a telescope. This device, invented by a Dutch spectacle maker named Hans Lippershey, could make distant objects appear much closer. Galileo was intrigued and decided to build his own. Within a month, he had constructed a telescope that could magnify objects 9 times, and by the end of the year, he had improved it to magnify objects 30 times. This was the beginning of a journey that would challenge the very foundations of the world as people knew it. Galileo's first act with his new telescope was to present it to the Venetian Senate. He knew that a device that could make distant objects appear close would be valuable for military and maritime purposes. The Senate was impressed and rewarded Galileo with a lifetime appointment as a professor and a significant increase in his salary. But Galileo had bigger plans. He turned his telescope to the skies, and what he saw would change the course of history. In March 1610, Galileo published a small pamphlet called The Starry Messenger, Sidereus Nuncius. In it, he described his astonishing discoveries. He had observed that the moon was not a perfect sphere, but a rough, cratered surface. He had seen stars that were invisible to the naked eye, and he had discovered 4 moons orbiting Jupiter. These findings were groundbreaking because they contradicted the prevailing Aristotelian view of the universe, which held that the heavens were perfect and unchanging. The Aristotelian Ptolemaic model of the universe, which had dominated Western thought for centuries, placed Earth at the center of the universe, surrounded by perfect, unchanging spheres. The stars were thought to be fixed points of light on a celestial sphere, and the planets moved in complex, circular orbits. This model was deeply ingrained in both science and religion, and it was considered heretical to challenge it. Galileo's discoveries were a direct challenge to this model. By showing that the moon had a rough surface and that there were countless stars beyond what was visible to the naked eye, he shattered the idea of a perfect, unchanging heavens. The discovery of the moons of Jupiter was particularly significant because it showed that not everything in the universe orbited the Earth. This suggested that the Earth was not the center of the universe, and that other planets could have their own moons. Galileo's findings were met with skepticism and hostility from many of his contemporaries. Some, like the Aristotelian philosopher Cesare Cremonini, refused to even look through the telescope, dismissing Galileo's discoveries as mere illusions. Others, like the mathematician and astronomer Giovanni Camillo Arrighetti, spent days testing the telescope and concluded that it was deceptive. Despite this resistance, Galileo continued to refine his telescope and make more observations. One of Galileo's most significant observations was the phases of Venus. He noticed that Venus went through phases similar to the moon, which provided strong evidence that Venus orbited the Sun. This was a crucial piece of evidence for the Copernican model of the universe, which placed the Sun at the center and the planets, including Earth, orbiting around it. Galileo's observations of the phases of Venus were a direct challenge to the Ptolemaic model, which could not explain these phases. Galileo's discoveries also had profound philosophical and theological implications. The idea of a perfect, unchanging heavens was deeply tied to the concept of a perfect, unchanging God. By showing that the heavens were not perfect, Galileo was challenging not just the scientific understanding of the universe, but also the religious beliefs of his time. This made his work particularly controversial and dangerous. Despite the resistance, Galileo's work gained supporters. Johannes Kepler, a German astronomer and mathematician, was one of Galileo's strongest advocates. Kepler had already published works supporting the Copernican model, and he was thrilled to see empirical evidence that confirmed his theories. Kepler wrote 2 books in support of Galileo's discoveries, helping to spread the word and lend credibility to Galileo's work. Galileo's career also benefited from his discoveries. In 1610, he was appointed chief mathematician of the University of Pisa and philosopher of the Grand Duke by the Grand Duke Cosimo II de' Medici. This position gave Galileo the freedom to pursue his astronomical interests without the constraints of teaching or residency requirements. He continued to make observations and publish his findings, further challenging the Ptolemaic model. However, Galileo's work also attracted the attention of the Roman Catholic Church. The Church was deeply invested in the Ptolemaic model because it aligned with their theological beliefs. In 1616, the Church issued a decree condemning the Copernican model as foolish and absurd in philosophy, and formally heretical since it explicitly contradicts in many places the sense of Holy Scripture. Galileo was ordered to stop teaching and advocating for the Copernican model. Despite this order, Galileo continued to work on his theories in secret. In 1632, he published Dialogue Concerning the Two Chief World Systems, a book that compared the Ptolemaic and Copernican models. The book was written in the form of a dialogue between 3 characters: Salviati, who supported the Copernican model; Sagredo, who was initially neutral but became convinced by the arguments; and Simplicio, who defended the Ptolemaic model. The book was a brilliant piece of rhetoric that made a strong case for the Copernican model. However, the publication of Dialogue was seen as a direct challenge to the Church's authority. In 1633, Galileo was summoned to Rome to stand trial for heresy. He was found guilty and forced to recant his support for the Copernican model. He was placed under house arrest for the remainder of his life, but even under these conditions, he continued to work on his scientific theories. Galileo's trial and punishment were a significant setback for the advancement of science, but they also served to galvanize the scientific community. His work inspired future generations of scientists and thinkers to continue the quest for understanding the universe. The legacy of Galileo's discoveries is immense. His observations of the moon, the stars, and the planets challenged the prevailing scientific and religious dogmas of his time and laid the foundation for modern astronomy. Today, we take for granted the idea that the Earth is not the center of the universe, that the moon has a rough surface, and that there are countless stars beyond what we can see with the naked eye. But these ideas were once revolutionary and dangerous. Galileo's courage and persistence in the face of opposition and persecution make him one of the most important figures in the history of science. Galileo's story is not just about telescopes and planets. It's about the power of observation and the importance of questioning established beliefs. His work reminds us that science is a process of discovery, and that progress often comes from challenging the status quo. Galileo's legacy is a testament to the human spirit of curiosity and the relentless pursuit of truth, even in the face of adversity. So the next time you look up at the night sky, remember Galileo. Remember the man who dared to look through a simple telescope and see the universe in a new way. His discoveries changed the world, and his legacy continues to inspire us today.